This slide shows the scatter plot with the temperatures after sunrise. On the x-axis, we have the hours after sunrise, and on the y-axis, we have the temperatures in Fahrenheit. You'll notice at the bottom of this y-axis, we have this zigzag-looking symbol. This is called a break. It's used in place of having to write out all the numbers in between 0 and 60. So since the lowest temperature of our data set is a little bit below 60, it's unnecessary to write out all these extra temperatures. So breaks in graphs are really just used to make it less work to label and also to just make the graphs look visually neater instead of having like a big empty space on the bottom. So looking at this graph, we want to describe the relationship between the hours after sunrise x and the temperature y shown in the scatter plot. So what you'll notice is as x is increasing, as the hours are increasing, y, or the temperature, is also increasing. At some point, it does flatten out a little bit here, but what we're talking about is just the general trend of what we notice. So we describe this association or relationship between x and y values as a positive association. The definition of a positive association is when the y values tend to increase as the x values increase. You can also remember it as being a positive association because if we were to take a line and try to represent the general trend or the shape of our data set, we would end up getting a line that has a positive slope, right? A line that's going up from left to right. This line, if we wanted to draw it, this would be called the trend line, which makes sense because it's representing the trend. And as you can see, it does not necessarily go through every single point, but it can be used to just figure out what the general shape of our graph is or what the general trend of the data is. This next scatter plot shows the temperature after sunset. So what's the relationship between x representing the hours after sunset and y representing the temperature? We can see that as our x values are increasing, our y values are decreasing. So if the last one was called a positive association, then this one, where the y values are decreasing, would be called a negative association. So we can describe a negative association as when y values tend to decrease as the x values increase. You can also remember this as being a negative association because if we were to draw a trend line to represent this data, this trend line would have a negative slope. This graph shows the rainfall in inches after sunset. We have the same question where we want to figure out the relationship between x and y values. So you can ask yourself without even looking at the graph first, do the hours after sunset have any relationship with rainfall? They shouldn't be related to each other, right? So when we look at the graph, that makes sense. We see that there's no trend in the data, so we describe graphs that look like this as having no association. Okay? Pause the video for a moment and try to think about how you would identify each of these and what type of association they would have. For this first one, as the x values increase, the y values also increase. So since they are both increasing, we would describe this as a positive association. For this one, as the x values are increasing, there's no real pattern for the y values. They're kind of all over the place. So we would describe this as having no association. So go ahead and drag and drop each scatter plot and situation into the most appropriate section of the table below. Pause the video, try to do it yourself first, and then you can check your answers. Here are the answers for each scatter plot and situation. I'm going to go through the answers one by one. So this would be described as a positive association because as my x values increase, my y values also increase. If I were to draw a line to represent my trend line of this data, I would have a line that has a positive slope. This one would be a negative association because as my x values increase, my y values decrease. If I were to draw a trend line here, we would have a line with a negative slope. This one would be no association. As my x values increase, there's no association with the y values. So these two data sets, whatever they were, the x and y values don't have an association. For this first one, time spent running and number of calories burned, this would be a positive association because the more time you spend running, the more calories you burn. They're both increasing. This would also be a positive association because the higher your grade level, the older you are. This would be an example of a negative association because as the temperature at a soccer game decreases, as it gets colder and colder, more people would end up buying hot chocolates. So if you want to consider as X or as the temperature is increasing, then the number of hot chocolates would be decreasing. As it gets warmer, less people are going to be buying hot chocolates. This would also be a negative association because as years go on, DVDs get more out of date, but if you compared it to like 10 years ago, DVDs were more popular. So as time goes on, as X increases, Y, the number of DVDs sold, would decrease. Height and math test average are thankfully an example of two data sets that have no association. Whatever your height is will have no relationship with what your test score should be. And finally, the amount of time spent shopping for Christmas gifts and how much someone likes your gift should have no association because what matters is that it's a gift from the heart. So I hope that this helped you practice identifying positive, negative, and no associations with two data sets and also give you a little bit of inspiration for you to come up with your own examples.